Okay, so last lesson, we learned how to factor polynomials using 3 different methods. And in this video, we're going to learn one additional method, plus in class we'll end up practicing more to make sure you understand all 4 of these methods. And that'll be good. So our first problem right here, our do now for today, is reviewing the toughest of the 3 methods from last time, which is that sum and difference of cubes. So I want you to go ahead and try this problem out on your own. Please pause the video and try and see if you can factor and solve it without my help. I do recommend that you write down the formula before you do it. So again, I'll show you this and then you can pause me. When you're doing these, I usually write out both formulas, even if I don't need them, and I just write them from scratch like this. So again, it goes AB, and then it goes A squared, AB, B squared, minus 1 per formula. On the bottom formula, it's here right away, so it goes plus plus. And then on the top formula, the minus is in the middle, plus, plus. I need the bottom formula, so go ahead and set this problem up, factor it, and solve it. Pause the video. So now you have paused the video, you have tried this problem out, you have just an amazing solution written down in your own notes. This parenthesis would be a 2x, and this parenthesis would be a 5. So my A is a 2x and my B is a 5. And then I go to set this up using my bottom row. I'm going to have just easy 2x minus 5. And then it's going to go. The part kids always screw up is right here. A squared means 2x times 2x, which is a 4x squared. So I got myself a 4x squared for that first part, not a 2x squared. Then it goes plus AB. 2x times 5 is 10x. Plus b squared, 5 squared is 25. And then it would be time to actually solve this. Incidentally, I have kids who sometimes want to FOIL these after they get here. I don't know why that pops in kids' heads sometimes, but it does. If you FOIL these, a bunch of stuff cancels and you just get back to where you started. So after you factor, you want to get x and actually get your solutions here. So one answer is real easy. You're going to get x equals a 5 over 2. And then for the other answer, what you're going to want to do is you're going to want to throw this in the quad formula. I'm going to go ahead and skip the work on that. You should end up getting for your answer, it's negative 5 over 4 plus or minus, it's 5i root 3 over 4 if you reduce it. It starts out, it's at negative 300 under the square root, so it's 10i root 3 over 8, and then you can reduce. I'm going to move the I to the edge though, and I'm going to put 5 root 3 over 4i, like this. If your I is up here, that's totally fine, it's the same thing. So yeah, that's our do now, reviewing what we learned about last time. We have one more factoring trick, and by no means is this the last way you can factor polynomials. It's just we're focusing on 4 in this class. In later lessons, we'll learn other strategies besides factoring for solving polynomials, but for now, we just have one more method to talk about. And this is my own made-up name, but I think it's more helpful than the real name. The real name is called quadratic form, but with a problem like this, I call this the full power, half power, no power rule. So if you look at this example, the challenge with problems in general with factoring is going to be, on a quiz or something, I'm not going to be like, oh guys, use the GCF method. Oh, you have to group here. I'm just going to give you a problem and you have to figure out which method to use. So let's review our 3 methods. First of all, the third method right here, very obviously isn't going to work on this problem. It's not a cubed problem and it's not 2 pieces. So that's out. Our first method was a GCF. And if you try pulling a GCF out of all of these, you can only take a 1 out for one thing. But even if you could take out a number, you can't take x's out because there is a plain number right here. Kids might say, oh, well, can't I just subtract 4 and then take x's out? But then the problem doesn't equal 0 anymore and you can't solve it with the 0 product property. So GCF method is out. And grouping, that second method, needs 4 pieces. So obviously that's not going to work either. So when you see a setup like this, something else I will see kids do that's a really bad thing is I will have kids who will take that problem and throw it into this guy anyway, the quad formula. That is a really bad thing to do. Never do that, please. It is called the quadratic formula. It only works on x squared problems. So if I ever see you throw a problem like this into the quad formula, that's a pretty bad thing to do. So this pattern, or this trick, only works when your exponents go full power, half power, no power. So what that means is you have an exponent. You have half of that exponent. So I have 4x's, I have 2x's, and then you have no exponent at all. Here I started 6th power, 3rd power, no power. That's cool too. So like this first problem, if this was a 5 and this was a 2, you can't use this rule. It only works when your exponents follow that pattern. Full power, half power, no power. And it turns out our method is just doing magic numbers. So I'm going to do magic numbers on this problem even though it's a 4th power. My numbers need to add to 29 and they need to multiply to 100. They end up being a 25 and a 4. And I think it makes the most sense to do them in this order, 25 first. The only difference is here. When you're writing this out, that's obviously still a 4th power. And when you split up the middle guy, it's going to keep whatever this variable is. So instead of 25x, 4x, it's going to go 25x squared, 4x squared. So you just mimic whatever variable is right there, and then plus 4. So now I'm just doing regular factoring stuff. If I group up those two, I can take out a 25x squared, and it's going to go x squared plus 1. And then over here, I can take out a 4, and it's going to go x squared plus 1. So parentheses match, that is so great. It means I did it right. I got this, I got this, and then I just solve both of those. Those are both binomials here. The square root method is going to be our easiest option. So if I write down this first guy, 25x squared plus 4 equals 0, subtract 4, divide by 25. And then I'm going to take a square root on both sides. I get for this part, x equals plus or minus 2 over 5, and then I, because it's a negative. So that's 2 answers for me right there. Then I also have to solve this guy. Subtract the 1. Square root both sides. That's going to be just x equals plus or minus 1i, or just I. So I box up my answers right here. Have I found all of my answers? I was supposed to have 4 answers. I have 1, 2, 3, 4 answers because of the plus or minuses. So yes, I do. Problem is over. And then one more example for this video here. This problem is full power, half power, no power, but it says to factor, not to solve. Because there's no equal sign in this problem. It doesn't equal 0. All I'm going to do is set up my magic numbers. So pause and do your magic numbers yourself for this example, and I'll work through it real quick up here. Semi-quick at least. What is that? 4 times 18? Yeah, I think that's right. 18 and negative 4 are going to be my magic numbers. So I get x to the 6th. When I split up my middle guy, I have to do x to the 3rds this time. And maybe it would have been easier to go the other way and put the 4 first, but oh well, I'll get the same answer. I'm going to have x to the 3rd that I can take out, and then it's going to be x to the 3rd plus 18. And then over here I can take out a negative 4. It'll go x to the 3rd plus 18. So my parentheses are going to say x to the 3rd minus 4 and x to the 3rd plus 18. Now again, this problem did not say solve, so I don't equal these to 0, which is actually a good thing because I don't know how to solve this or this yet. This sort of looks like my sum and difference of cubes from last time. So it looks a lot like this method right here. The thing about these two, though, are 18 and 4 aren't perfect cubes. They don't work out nicely. So that wouldn't end up working out for me, but that's okay, because the problem just said to factor. So the trick with this lesson is going to be making sure you can keep straight when to use each of our 4 methods. And then as we progress later in the chapter, we'll learn about other strategies for when factoring doesn't work.